Meta just dropped their first real AI coding agent. And when I say just, I mean literally hours before we hit record for this explainer. We are looking at a brand new day one release. Today, we're going to break down exactly what Muse Code is, what it actually does under the hood, and how it stacks up against the heavyweights that have absolutely dominated this space until now. Hey everyone, Techie here from AI Tech Hub. Now, if you caught our recent explainers on Cloud Code or Amazon Q Developer, you already know this space is moving ridiculously fast. Well, Muse Code is stepping into that exact same arena. We're talking about agentic coding tools, stuff that doesn't just autocomplete a line of code, but actually plans, writes, and verifies whole chunks of it, totally on its own. So let's just dive right in. We're splitting this into two parts today. First, the mechanics of what Muse Code actually does, and second, how it really compares to the competition. All right, Section 1, what it actually does. Right off the bat, you gotta know that Muse Code is strictly a terminal-based agent. You install it with just a single curl command. Right now, it's built for macOS and Linux environments, which honestly perfectly captures this no-nonsense, highly developer-centric vibe Meta's going for here. You're not downloading some bloated graphical suite, you know? You're pulling a tool straight into the command line, which is where we're already spending most of our time anyway. Under the hood, this whole thing is powered by an engine called Muse Spark 1.2. That's Meta's in-house proprietary AI model laser-focused on coding. They didn't just take a generic chatbot and cram it into a terminal. Actually, they specifically designed Muse Spark 1.2 to handle, in their words, complete software engineering tasks across large repos. The key takeaway there is that it's built to actually understand the architecture of your entire project, rather than just getting stuck looking at a single file in isolation. So how does it actually execute on that? Well, it uses that exact same core agentic loop we covered in our Claude Code Explainer. When you hit it with a prompt, it doesn't just start blindly spitting out code. First, it explores your code base to grab all the context it needs. Second, it plans out the necessary changes. Third, it acts. It writes the actual code. And fourth, it verifies those changes to make sure they didn't break anything. It is a continuous, self-correcting loop. But here's where it gets really interesting, how it handles scale. If you toss it a massive job, Muse Code doesn't just painfully chug along file by file one at a time. It can actually fan out into separate parallel subagents. And each of those subagents gets its very own isolated work tree. That means multiple parts of a huge task can progress simultaneously. It's kind of like suddenly being handed a whole team of junior devs who can all work in parallel, instead of just one guy trying to do the whole thing step by step. Another crucial mechanical feature you need to know about is the local event log. Muse Code is super rigorous about this. It locally records every single model call, every tool it uses, every time you approve something, and every file edit. And why is that a big deal? Well, imagine you're running this massive, complex task. It's been going for 20 minutes, and right at minute 19, your machine crashes. We have all been there. With Muse Code, you don't lose the whole shebang. The agent just reads the log and picks up exactly where it left off. For large-scale stuff, that's an absolute lifesaver. Okay, but let's be real for a second and talk limitations. Unlike a lot of its biggest competitors, Muse Code does not have a dedicated graphical app interface right now. Zero. It is strictly terminal only. So if you're someone who relies on clicking through a nice polished UI, or you like having your agent tucked neatly into a side panel in a standalone app, yeah, you are not getting that on day one. You've got to be completely comfortable living in the command line. Moving on to Section 2, how it actually compares. When you stack up the interfaces, the contrast is pretty wild. On one side, you have tools like Claude Code and Codex that give you highly flexible ways to work, deep editor integrations, broader graphical options. And then there's Muse Code, keeping things incredibly simple, but yeah, arguably way less flexible by funneling everything strictly through the terminal. It's a very deliberate design choice. It's going to completely appeal to some developers and honestly, totally alienate others. Let's talk performance benchmarks. Now, just sticking to the facts based on Meta's own reports, the original Muse Spark model was hitting around 77.4 on standard coding benchmarks. If you look at the competing frontier models, they generally sit closer to that 80 or 81 mark on those exact same tests. So, historically speaking, Meta has trailed just a tiny bit behind the absolute bleeding edge in this specific metric. But here's a really vital detail. Meta actually didn't headline any specific benchmark numbers for this brand new 1.2 version at launch. And honestly, in the AI space, We never take day one first-party claims at face value anyway. So the big takeaway here is that we're all just waiting on independent, real-world testing to see if Muse Spark 1.2 actually closes that gap with the top frontier models. Now this right here is where Muse Code completely separates itself from the pack. Meta is rolling out a dual-tier pricing model, and it forces a very, very explicit trade-off. There's a standard tier priced at your typical market rate, and crucially, this keeps all your proprietary code completely private. But then they've got this contributor tier. This tier is highly discounted, but, and it's a massive but, in exchange, you are explicitly giving Meta permission to use your prompts and your code base to train their future AI models. And when I say highly discounted, I am not kidding. Depending on your input to output token ratio, the contributor tier is roughly 10 to 20 times cheaper than the standard tier. We're talking a fraction of the cost. This isn't just some minor little promo code. This is a dramatic, fundamental shift in the cost of running agentic AI. You just have to be willing to pay with your data instead of your wallet. Let's ground this in a real-world scenario. Imagine you're a solo developer, and you're tasked with refactoring this massive, messy, legacy code base. This is exactly the kind of sprawling nightmare job Muse Code is built for, with those parallel subagents, right? If you're working on a proprietary enterprise app, you just pick the standard tier, pay the market rate, and your client's data stays locked down and secure. But if you're just hacking together a personal open source project on a weekend, and budget is your main concern, you flip over to the contributor tier and get the entire job done for literal pennies on the dollar. It's a genuine choice, and honestly, it's one that most competitors simply aren't offering right now. All of this points to a really fascinating pivot for Meta. Historically, they've leaned so heavily into open source AI, right? I mean, their Llama models have been downloaded over 1 billion times. But Muse Code? This is a polished, highly competitive commercial product. They aren't just dropping model waves on a repo, they're launching a full-blown service. This shifts the entire landscape of coding assistants, and it's setting up a massive showdown in a market that Anthropic and OpenAI have completely dominated for the last year. So, that is Muse Code on day one, a really powerful terminal agent that brings a massive data for discounts trade-off to the table. Because it literally just dropped, we're still waiting on those independent benchmarks. If you want a follow-up explainer as soon as those numbers are verified, drop the word Muse in the comments below. But until then, it leaves us with one massive question. Can Meta's big commercial play actually earn developers' trust and steal the crown from Anthropic and OpenAI? I'm Techie, and I'll catch you in the next explainer.